No doubt the thing that comes into most people's minds when the subject of bird migration is mentioned is concentrations of birds during their migration flights. Particularly the migration of waterfowl probably is what is thought of first. Here we have a huge concentration of blue and snow geese out on one of the refuges in South Dakota as they move northward in the spring. Many thousands of people are now beginning to visit these migration places to really get the thrill out of watching these enormous flights of birds. There are many phases, of course, of the study of bird migration that are equally or even more interesting and much more amazing, perhaps, than these enormous concentrations of birds of this sort. And we're going to examine a number of these. Man, of course, has shown tremendous abilities in his capabilities in building of skyscrapers, projecting way up into the sky, and he's shown tremendous communications capabilities. His jet aircraft have almost annihilated distances, and he's learned how to trap atomic energy and use it for both war and for peace. But when we come to studying some of the mysteries concerned with the migration of birds, there are a good many questions that still remain as migration mysteries. Birds, of course, are not the only animals that migrate. In the Arctic tundras, there are large herds of caribou that travel in large circular patterns, circuit patterns over the Arctic, swimming across bodies of water of huge size, climbing up onto ice cakes. And the bison in early days also had large circular migration patterns that they traveled over our western prairies. Even the small insects like the monarch butterfly is an insect which travels as much as 2,000 miles during a season in migration. We, however, are not going to discuss migration in general, but the migration of birds in particular at this time. A good many birds are gregarious other than the waterfowl. This is a tremendous swarm of swallows, almost entirely purple martins, which were gathering over a cattail marsh in a swamp out in Minnesota, preparatory to their migration south. And blackbirds are rather noted for their gregarious habits, flocks of them coming up off of fields looking almost like a cloud of smoke. Other birds also are highly gregarious in their migrations. The mudhen or coot is a bird that comes together in large numbers, but we never see them migrating in flocks because they travel at night. The warblers are also gregarious, but they do not travel in formations or dense swarms, but they sort of filter through the treetops, only gathering close together around bird baths, perhaps, or favorable situations such as this. But dozens of different species may associate together in a migration of warblers. When we turn to the predatory birds like the hawks, some of the races of the red-tailed hawk, most of these are solitary, like the osprey or fishhawk, are solitary in their migration travels. Also the duckhawk, another one of the predatory forms, and the vulture, the turkey vulture, which travels north in the summer and south again in the winter, but to a large extent solitary. Most of these come together only where favorable wind currents will sometimes cause them to come to the same places, like at Hawk Mountain in Pennsylvania or at Duluth at the west end of Lake Superior. The ability of birds to fly, of course, is the thing that makes them so mobile and that makes their travels so interesting. The actual speed at which birds travel. Teal going over a duck pass often get over so fast that a hunter hardly gets time to bring up his gun and shoot. Actually, when it comes to speed, a 100-yard dash man travels at about 21 miles an hour, a trained racehorse about 40, and some of the fastest flying ducks, like the canvasback and pintail, will travel in still air as fast as 75 miles an hour. However, among the birds, the duckhawk and some of the large swifts have been clocked reasonably reliably at about 180 miles an hour. As far as altitude goes, a good many birds do some rather almost what you might consider impossible feats of high-altitude flying. Many of you probably have been up on top of Pike's Peak. Recently, I photographed this raven gyrating about very readily under his own power on the top of Pike's Peak, where we get a little bit woozy from exerting ourselves even just walking. The bar-headed goose of Asia may be the champion high-altitude flyer among birds. This is a bird nesting up in Tibet, migrating south in the fall to the Bay of Bengal in eastern India. And in this migration flight, these birds have been noted as flying over the top of the Himalaya Mountains and even over the top of Mount Everest, which is 29,000 feet high. Some of the altitudes that we're familiar with: the world's tallest building, 1,250 feet. The air pilots are advised to use an auxiliary oxygen supply above 14,000 feet. Some of these cranes and geese actually fly twice that high under their own power. So their ability to fly in rarefied atmosphere is one of the amazing things that birds are capable of doing. The simple matter of flying itself brings up a lot of anatomical points which are of interest. Birds that can fly like the bald eagle, and the pelican, of course, is a very clumsy-looking bird on land, but in the air, the pelican is really a master aerialist too. And we might take a look for a few moments at the skeleton of a pelican and see something about the structures which enables it to be such a master of flight. In the first place, all of the flying birds have a large keel on the breastbone for the attachment of the breast muscles, which extend up and are attached to the basal part of the humerus bone, the proximal bone of the wing, giving it its powers of flight. If we look at that humerus bone a little more closely and cut it in section, we find that the internal structure shows it to be a very, very thin-walled tube with cross members developed at points of strain, giving it greater strength with a very minimum of material. And the hollow bones are otherwise filled with warm air, too, which tend to buoy it up. The structure of a bird's flight feathers is really remarkable. The feather itself, of course, is made up of a series of interlocking segments, which can be badly disarranged readily, but with just a little bit of dressing, the feather all goes back into shape again without any damage whatsoever. The structure of the wing as a flying apparatus, the primaries rotate on the upbeat, allowing the air to pass through like a check valve, and it's trapped and produces a strong resistance to the air as the wing moves downward. So this rotating of the primary feathers is interesting. And of course, birds have had retractable landing gears since thousands of years in the past. The migration of birds has attracted the attention of man since the dawn of history, and even before, no doubt, since waterfowl particularly have supplied food for primitive man far, far back into the past. In some of the caves along some of the Illinois rivers, archaeologists have investigated the midden heaps of these primitive men and have found that at times they were living on as much as 70% of waterfowl, and the Canada goose and the mallard duck have been identified among the remains that these people have been using for food. And as a source of food, undoubtedly, waterfowl have served a great service to mankind from way back. One of the earliest records in history of bird migration being reported in any detail was in the Bible in the book of Exodus, where the quail came in around the camp of the children of Israel and provided them with sizable supplies of food. It seems impossible to modern man that the children of Israel wandered in this little triangular piece of land called the wilderness, where Asia, Europe, and Africa join. They wandered there for 40 years before arriving in their promised land, which was called Palestine, which we now know as Jordan and Israel, and some of the other Asia Minor areas. They wandered there just after their escape from bondage in Egypt, about 1800 BC. The little migratory quail was the species which was concerned with this particular record of bird migration. This is a very small quail as game birds go, but it reproduces in tremendously large numbers, and it's very unwary and can be readily captured. This is really a Eurasian species which nests or winters down in the northern part of Africa above the Sahara Desert, and it nests in southern Europe and in southwestern Asia. The migration of these birds takes them around the east end of the Mediterranean, and the first record of the children of Israel being fed by quail was when they were camped on the upper arm of the Red Sea, just northwest of Mount Sinai, where the record said a southwestern wind brought the birds to their camp. Later, they camped farther to the east on the Gulf of Aqaba, and there the record was that it was a southeast wind which brought the birds in. So this was some of the first data that's been recorded in history regarding the migration of birds. During the Christian era, very little was added to our knowledge of the migration of birds, and some strange ideas were held at those times. There was a publication in 1638 in England stating that birds went to the moon for the winter, and that man himself might reach the moon by the aid of a flock of swans, a rather far cry from our sophisticated moonshots that we're carrying out today. It had to wait for the explorer and his ability to write and to draw maps, record his observations, before we began accumulating very much data regarding the movements of birds, since they traveled so much farther than human beings did in those days, except those sea travelers who were making these observations and drawing these maps. Museum preparators, museum collectors began collecting birds from all over the world, bringing them together in large collections, carefully identifying them, and gradually accumulating the information that the same species of bird occurred in a number of different countries in different times of the year. And of course, this first required some very, very careful work on the identification of these birds, since birds' plumages changed, and a bird in one season might look quite different from what it might look at another. The crossbill, for instance, here, rather a grayish-brown bird during the fall or when it's young, and in the breeding period in the spring, being quite a bright red bird, looking entirely different. So it was the identification of these birds that soon brought about the information that, for instance, our bluebirds, which nest up in the northern part of the United States and southern Canada, are the same identical bluebirds that spend the winter down on the Mississippi Delta or along the Gulf of Mexico. And the blue-winged teal that court, choose their mates, and fight for territories up in the sunny meltwaters of Manitoba and other northern lakes were the same blue-winged teal which showed up in the wintertime down in Venezuela in northern South America. They began getting the information that the species appeared in these different areas at different times, but he soon became curious about how much traveling or what travel abilities did individual birds have. How far could these birds travel, and at what rate of speed? And a lot of questions like that came up about the movement of individual birds. And of course, the technique that was developed to determine this was the technique of bird banding. One of the very earliest records of bird banding that has come to the attention today was a record of a band that was placed on a European heron, which was a close relative of our great blue heron, down in Turkey, and later this bird was shot up in Germany, indicating that there was positive proof then of that much of travel that this individual had carried out. One of the earliest really scientific efforts to use numerically or serially numbered bird bands was by a Dr. Mortensen in Denmark, who began putting numbered aluminum bands onto birds, starlings in this case, in Denmark. He banded only a few hundred of these, but it was rather amazing how many returns he got. In about 1920, the U.S. Biological Survey, then now called the Fish and Wildlife Service, saw the research possibilities of bird banding, and they undertook the manufacture of bird bands, distributing them to qualified banders and gathering the data which they were able to secure from the banding of birds. And this has become a very widespread practice in research lately. Here's a new building at the Patuxent Wildlife Refuge at Laurel, Maryland, just out of Washington, D.C., where the data from these banding operations are kept. This is one day's mail of reports coming in from bands of birds picked up in various parts of the world. And the numbers have got so great that computers are now being used to digest and sort and handle the data that comes in. Lately, one of the techniques that is mainly responsible for large numbers of birds banded is the mist net, a rather difficult net to photograph because the idea is that it should be invisible. It's made out of very thin black thread, and the nets are stretched in favorable places. Birds fly into the net, become encased in a little sack of net, and they're banded and released. Here's one of the most complicated types of traps, the Heligoland trap, named after the island of Heligoland in the North Sea where it was first built. At the end of a hedge, the birds are chased into this long curving funnel, and a glass-covered box at the end of the funnel secures the birds. By these various methods of trapping and banding, all of our North American birds now are known where they travel for the winter. The chimney swift was one of our last ones to keep it a secret where it spent the winter. A number of these were banded in some large chimneys down in Tennessee and Kentucky. Later, several of these were shot and sent in by natives in Peru, in the high Andes Mountains, where they were confused with native South American swifts, and their identity as North American swifts had not been suspected. The whooping crane has a very simple type of migration travel. This is the spectacular large white bird, of which there are only 42 left in existence at the present time. This bird has come into the news a great deal in late years because it is so near the verge of extinction. This bird winters on the Aransas Refuge down on the coast of Texas and nests up near Great Slave Lake in northern Alberta and Saskatchewan. Here the birds drop down into the tundra, the Arctic tundra, near the tree line, where among the little scrubby spruce trees and on the sphagnum moss they hatch their young, and they return by essentially the same direct route. All birds do not have as simple a migration as this. Here we have the black-throated or Pacific loon, Arctic loon, a bird which nests around the North Pole. Those that nest in northern Russia, for instance, move south in the fall down to the Black Sea, over onto the Mediterranean, where they spend the winter. The frozen interior, then, forces them to go north, up a shorter jump to the Baltic Sea, and up across Lapland and northern Finland back to their nesting grounds in the northern Russia, a loop type of migration. One of the most interesting of the loop migrations is by the mutton bird, or one of the shearwaters, which nests out in the Pacific near Australia. Originally, this bird was described around Australia as being the short-tailed shearwater, and later on another species of shearwater, which was found up around Japan and north, was called the slender-billed shearwater. Later it was discovered by the technique of banding that these two birds were not different species, but one and the same bird. And the result was arrived at because of the extremely long migration of this bird, and the two populations were not thought of as the same. After nesting around Tasmania in southern Australia, the birds moved north through the East India Islands, on up past Japan, and moving on north past the Kamchatka Peninsula of Siberia, the Bering Sea, some of them even moving north into the Arctic Ocean. Then they turn about, move southeast, down across along the coast of British Columbia and western U.S., then by a 7,000-mile cross the Pacific jump, they return to their nesting grounds in the Bass Straits between Australia and Tasmania. And the remarkable thing about it is they arrive almost identically the same day every year. Another interesting migration pattern is carried out by the fox sparrow, one of our common sparrows throughout a large part of the United States. One population nests around Puget Sound and Vancouver Island, which does not migrate at all. Race number 2 nests along the British Columbia coast farther to the north, and in the fall migrates down south to spend the winter in western Oregon. There is still another race of the fox sparrow that nests up in southeastern Alaska, number 3, which moves still farther to the south, wintering down around San Francisco Bay in California. And the other races, which nest along southern Alaska and out on the Aleutian Islands, move still farther to the south, wintering down in southern California. So the farthest north nesting race goes farthest south to spend the winter, a sort of a leapfrog process, and this is carried on by some other species too. The various races of the Canada goose do essentially this same type of migrating. Well, migration is not always east and west, north and south. The evening grosbeak, the large bird, the name grosbeak means large bill, of course. A large sparrow is what it is. Many of those that are nesting are banded in northern Minnesota, which are later picked up in the New England states, almost a direct east and west migration. When it comes to their travels, of course, birds encounter a great many hazards during these long trips. And the hunting of waterfowl, of course, man's hunting, is one of the big hazards that waterfowl encounter. Since this is probably the best known, the most legislated about, the most discussed, the most written about of all bird hazards, we're going to pass over this, simply mentioning it as a serious hazard for waterfowl, and we're going to move on to some of the other hazards that migrating birds experience. One of these is of recent origin. Many of you probably know of Rachel Carson's book, Silent Spring, where the discussion of sprays, chemical sprays, have come up. This is definitely a hazard to a great many migrant birds as well as resident birds. And as you look over the shelves in a nursery or a garden store, you'll see literally hundreds of spray combinations of chemicals that have been that are being manufactured and distributed for the control of insects and weeds. A recent Encyclopedia of Chemistry listed 115,000 new chemical compounds in 1 year. Not all of these, of course, were pesticides, but a good many of them were. And we must admit that the farmers are using these to great advantage in raising better crops and getting larger production on the same acreage with many less man-hours consumed. So there are many advantages in the uses of these chemical sprays, but at the same time they're causing a good deal of damage to wildlife. Robins particularly have been the victims in many, many cases. In spraying for the Dutch elm disease with DDT, a great deal of DDT gets into the soil under the trees, and a careful check on the soil has come up in one experiment with 9 parts per million of DDT in the soil. The angleworms feeding in that soil build up that concentration to 150 parts per million, which apparently does not damage the angleworms, strangely enough. The robins come along and feed on the angleworms, and they build up the concentration of DDT still farther, so that the brain of robins there have been examined and checked as having as much as 450 parts per million, which is a lethal dose for the robin. And in many, many places where heavy spraying with DDT for Dutch elm disease has been carried out, robins will be found in this condition, gradually becoming paralyzed after accumulating a lethal dose of DDT until they finally die. Literally thousands of robins were killed in Minneapolis just a couple of years ago by this process. Water birds are also subject to this same type of destruction. The western grebe migrated and stopped on Clear Lake in California in large numbers. The spraying along the shore that was carried out with DDT for the control of a certain abundant gnat was washed into the water. The fish picked up a great deal of the DDT. The western grebes feeding on the fish built up a lethal concentration until hundreds of these western grebes were killed through that process, the food chain as it's referred to. We hope that we can still have the benefits of chemical sprays, but that we can learn how to avoid the damage to our wildlife with the use of this type of product. Another hazard concerns our feeding of birds. We often feed them with sunflower seeds and suet and oranges in order to bring birds in around our homes so we can enjoy them. But unfortunately, the larger our windows become, the more often birds confuse the reflections in windows with places where they can fly through. And a great many birds are killed by flying into glass. An inconspicuously marked little bird like an ovenbird lying among the leaves would probably go unnoticed. But if it is a junco that happens to fly into a glass door, drops on a sidewalk, very conspicuous. Actually, architects are beginning to use larger and larger areas of glass in construction of all kinds, and where these are placed, where migrating birds are traveling, the toll of migrant birds is really becoming quite a sizable toll. Some of my neighbors and friends have been using just sticker tape put onto the window and have reported a somewhat of a reduction in the kill of birds. Predators are another source of damage to migrants. Some of you probably played fox and goose when you were youngsters in the snow. Here's a real genuine fox and goose game. A fox apparently studying this flock of migrant geese, trying to figure out how to get a goose for dinner. When birds drop into unfamiliar territory, the predators there probably do take a heavy toll. A man-made hazard which has come in for a great deal of attention in late years is oil pollution, particularly on the oceans, ocean beaches, although not exclusively so. This was the case in the Mississippi River just below Minneapolis-St. Paul, where petroleum and soybean oil accidentally was dumped into the river. The little skim of oil got onto the ducks dropping into the bays and quiet backwaters. Here was a ringneck duck, which had become so saturated with oil it could no longer not only swim, but it could not even stay afloat. So it's gone to land in order to survive. But of course, a stray cat or dog or skunk or fox or some predator will undoubtedly find the bird sooner or later, and it will perish. In this instance, a good many well-meaning sportsmen brought their retriever dogs down and searched the shores of the river. They picked up several thousands of these ducks that had been saturated with oil and attempted to rescue them, wash them out, and to see if they could be carried through to survival. A female wood duck here. Actually, I believe less than 5% of these birds survived. Over 5,000 birds died in this one case of oil pollution. And of course, on the sea beaches where tankers are washing out their oil tanks, many, many thousands of birds die. Another source of some hazard is actually hailstorms. Here was a situation down in Texas where over 1,000 very large Sandhill cranes were beaten into the ground and killed by a heavy hailstorm. Another man-made hazard that is taking quite a toll of birds is tall smokestacks and water towers and buildings of various sorts, but particularly the extremely tall radio and TV towers that are now being built. Up to 1,000 feet high, a good many of them, and recently some are going up as high as 2,000 feet. The flashing red lights on these towers enable airmen to avoid the towers, but they actually, if anything, serve to attract birds to them. And the towers and the guy wires really kill tremendous numbers of birds at times. This is a part of the kill at a tower at Eau Claire, Wisconsin, where over 20,000 birds were killed in one night. These take place during foggy, rainy nights in the fall, usually. Fortunately, not every night causes a casualty like this, or our birds would be entirely gone, probably. But on favorable, or what you might call unfavorable nights, the casualties really run very, very high. Apparently, no solution has been worked out for avoiding this tremendous kill of night-flying birds. The fact that a good many birds are killed at these towers during the nights points out that many birds do travel at night, and this is a hard problem to get data on. With regard to this, Doctors Lowry and Newman at New Orleans, or at Baton Rouge, Louisiana State University, hit upon the idea of studying the surface of the full moon and recording the birds that flew across the face of the moon. By securing data of this sort, a good deal has been learned about the night flights of birds. The moon's face is considered to be the face of a clock by the observers, and the direction of flight across the face of the moon can readily be recorded as flying between certain hours on the face of the clock. Here, for instance, from 5 to 10:30. The birds seen by an observer here, of course, are only those that fly through the cone of vision from the observer's eye to the outside margins of the moon, and of course below the flight ceiling, the level at which birds fly. These data are accumulated, treated in a complicated mathematic manner, deriving a number of birds per mile that are being observed. One of the problems that has been clarified a good deal by this technique has been the quantity, the magnitude of the flight between Yucatan and Louisiana across the Gulf of Mexico. Since birds fly at night and under unfavorable conditions, we often wonder whether they have built-in compasses of some sort which enable them to fly in the desired direction. Some birds, it seems, do have such a compass. The Manx shearwater is a type of seabird which nests on an island, Skokholm Island, off of the coast of Wales. Some of these birds were taken off their nests, flown by plane to the Boston airport, where they were released, and in 12 and a half days, some of these birds returned onto their nest clear across the Atlantic Ocean. Similarly, in the Pacific, the Laysan albatross, or Goonie bird, as the Navy and Air Force people referred to them during the war, these birds nested on Midway Island, way out in the center of the Pacific. Some of these birds were flown back to Seattle, Washington, where they were released, and 10 days later, some of those were back on their nest on Midway Island. One of the most remarkable travels of all of our birds is by the little tiny golden-crowned and white-crowned sparrows, which nest in California, or which winter in California. Some of these visited the yard of Dr. Mewald at San Jose University. He knew that these birds nested in northern British Columbia. Later, the next winter, he again captured these, sent some of them to Louisiana, where they were released, and apparently these birds returned to their nesting grounds in northern British Columbia, and again down to San Jose in California, where Dr. Mewald caught them again in his backyard. He took again some of these same individuals, sent them clear to Washington, D.C., where they were released, and they traveled again, apparently, clear up to their breeding grounds in British Columbia and back to be recaptured in Dr. Mewald's backyard. A most remarkable travel for such a tiny bird. Other birds, such as the hooded crow of Europe, appear to inherit an ability to fly in a certain direction rather than to go to a certain area. Birds trapped at Rossetten in the southeast shore of the Baltic Sea migrated north and were found nesting in Lapland and northern Finland. Some of these birds were trapped and shipped to Denmark, where they were released, and many of those nested in Sweden, again northeast of the release point, but not in their natural habitat over in Lapland and northern Finland. So apparently the hooded crow inherits this ability to travel in a specific direction rather than to go to a certain place. Another remarkable case was that of a bobolink. Dr. Hamilton was doing experimental work with orientation with birds out at the University of California in Berkeley. He wanted to use bobolinks for his experimental birds, but they did not nest and inhabit California. So he wrote to some avid bird banders in North Dakota, Dr. and Mrs. Gamble, and they captured some bobolinks, sent them to him. One of these birds, banded, escaped during the experiment, and it flew southeast, which was the normal migrating direction for North Dakota bobolinks. They then had to move a bit eastward across Central America, down across South America, apparently meeting up with other bobolinks in Argentina and returning with them across the West Indies up to North Dakota, where Dr. and Mrs. Gamble captured the same bobolinks with bands indicating they were the same individuals that were in California. Dr. Kramer, a German ornithologist, was the first one to definitely prove that birds actually use the sun to indicate their direction of travel. He captured birds and put them inside of a circular cage on circular perches where there would be no corners to give the bird any orientation indications. It was free to face in any direction it wished, and it was found that the birds would face the direction in which they would normally migrate while they were kept in these circular cages. As the sun moved from from east to up over the horizon and west, the birds continued to orient themselves southeast. During cloudy days, when there was no sun visible, the birds did not seem to be able to orient themselves correctly. Then, by blocking off windows into these circular cages and reflecting the eastern sun so as to make it rise in the south, and to move over the west and set in the north. Notice the bird has changed its migration or pattern to southwest rather than southeast, indicating that it was using the sun as its key to orienting its direction of flight. A student of Dr. Kramer's, Dr. Sauer, wondered about night flights, and by exposing the birds at night, on clear nights, the birds would face their normal migrating direction, the same as they did during the day. However, when he placed these birds on cloudy nights, they did not seem to have this ability. He then put them in a planetarium where he could control the sky, and by blocking out some of the major constellations, he soon forced the bird to lose its way, so to speak. It lacked its orientation ability. A little lesser whitethroat was a remarkable bird in this experiment. This bird was a bird nesting in Germany. Its normal migration route was to the southeast, around the east end of the Mediterranean Sea. If the sky in the planetarium, the constellations, were made to represent Russia 1,000 miles to the east, the bird then oriented west, as though it wished to return to Germany. If the sky was to represent Central Africa, where the bird winters, the bird then did not orient at all, indicating that at that season it had already arrived in its wintering grounds. Since this was such a remarkable result, we're anxious that other ornithologists should test out other species of birds and see whether they too, as well as the little lesser whitethroat, are capable of orienting as effectively as this by the stars. The question of what is the triggering apparatus that causes birds to start off on their migration flights at the right time? What is it that enables the whistling swans that take off at Chesapeake Bay to move northwest away up to their nesting grounds in northern Alaska and northern Canada? Well, Dr. Rowan, working at Edmonton at the University of Alberta, was the first to pretty conclusively prove that it was the length of day which was the triggering factor in this particular case. He captured crows, which were definitely migratory at Edmonton, put them in cages, and fed them and kept them in good health, but kept them outdoors where they'd be exposed to the same cold temperatures that normal birds would in Edmonton during the winter. Juncos also were used in this experiment. He captured them in the early part of the winter before they had migrated to the south, kept them in captivity, and then by artificial light he lengthened the days to which the birds were exposed to the point where in mid-December they were getting length of day which they normally would get in the spring in May. The gonads of birds, the sex organs, enlarge rapidly during the spring, just previous to the nesting season. These birds, exposed to artificially lengthened days, had their ovaries and gonads develop the same as in birds normally exposed in the spring. And at the same time these gonads were enlarging, the migration urge built up very definitely, and this was proved since Dr. Rowan released a number of these birds after they had been exposed to the long days, and a number of them tended to migrate north and not remain stationary or go south as you would expect them to in the middle of the winter. Control birds not exposed to lengthening days, their gonads remained small, and they showed no indication of migrating. Since then, a great many experimenters have worked with lengthening days and its result on birds, and it is now known that the light affects the birds through the ductless glands of the body, the pituitary gland, for instance, a tiny gland up associated with the brain, and the adrenal gland attached to the kidney, and the thymus gland in the neck. These are all ductless glands putting out hormones which cause the gonads to enlarge and apparently cause the triggering of the migrating instinct. So birds like the red-winged and yellow-headed blackbirds that are migrating are not migrating just because of ideas they get in their heads, but very complicated physiological changes are taking place in their bodies due to the lengthening of days. The energy consumed by parasitic Jaegers or long-tailed Jaegers in their flight. Birds of this size, we often wonder how much energy birds of different sizes are going to expend in flying. The Physiological Laboratory, no doubt, will bring the answers to this, and they're already bringing some of the answers. Dr. Lefebvre at the University of Minnesota used homing pigeons in his experiments because, as you well know, they return to a loft after long-distance flights and may be recaptured immediately after a flight. We've known for years that fat, of course, is the fuel which supplies the engine, so to speak, of birds in flight. And it's been known for a long time that the amount of fat utilized by a bird resting in a closed chamber where the oxygen and carbon dioxide produced and consumed by the bird at rest, the basal metabolism, can be calculated quite accurately. Even for man, of course, this can be determined readily, the amount of energy he consumes in living. But in getting this data, this type of data from a free-flying bird was quite a different problem. Suffice it to say here that heavy water was used in this experiment, and it was possible through complicated measurements to add heavy water to the drinking water of homing pigeons just previous to their taking off on a long-distance flight. The birds had a tiny blood sample taken after they had drunk the heavy water and the balance attained in their body fluids. These samples were carefully checked, and then the birds were released. They circled about, orienting themselves with other birds that were on a flight of this sort. Then they pick up their direction and fly directly back to their loft. And in this experiment, the distance traveled was about 300 miles. We took the birds from Minneapolis back down to Missouri-Iowa line. Here's the actual experimental bird returning to the loft just outside of Minneapolis after its 300-mile flight. The bird, of course, returned immediately to the loft and was captured, and again, tiny blood samples were taken, and a very, very careful and exhaustive measurements were made of the tiny samples of blood removed from the bird, and by these complicated measurements, it was discovered that that particular bird in flying 300 miles utilized 4 1/4 teaspoons, 19.9 grams of fat. A carrier pigeon, a homing pigeon, is known to be able to carry about twice that amount of fat. So the determination was that a homing pigeon could fly about 600 miles, about the distance from Cleveland to Minneapolis, nonstop. And the pigeon racers say that this is essentially what they are able to do. If they fly farther, they usually have to stop and feed and water on the way. Carrying this calculation to what might be called a ridiculous extreme, a pigeon could fly a little over twice around the world on 1 gallon of fuel of this sort. Birds like these cranes flying by a radar station, of course, have no realization that that radar station may be picking up additional information for us regarding their movements. These big white domes, which you see scattered here and there over the landscape, are, of course, the big plastic covers over the rotating heads of the radars, which are throwing out rays which reflect back at the speed of light, and these signals are picked up in that way. The tremendous cost involved in the developing of radar was justified on the basis that it was used during wartime for detecting the presence and movements of bombing planes and helicopters and even weather fronts. Here we have a work print of a radar screen. The little flickering lights the early radar operators could not explain, and for want of an explanation, they simply called them angels. A researcher in Switzerland finally determined, and proved that these flickerings were actually returning reflections from birds. And since then, the study of birds has been helped a good deal by radar. You are familiar with the hooked outline of Cape Cod in Massachusetts. Here it shows up on a radar screen. Apparently, the reflected light spots are from water birds, gulls and ducks and geese, and various birds over the water, which leaves the hook pattern of Cape Cod silhouetted on the screen. Radar units found heavy migrations of birds coming inland over the coast of New Jersey in one experiment, while ground observers were reporting heavy flights paralleling the shore. So we got contradicting evidence here. Apparently there were two migrations that were quite different in their nature. Radar does have a lot of difficulties, a lot of shortcomings in explaining and helping us with bird study and migration, but they have aided in getting certain types of data about the migratory movements of birds. Other long-distance flights of birds are being studied by the newly developed tiny transistorized radio broadcasting units. This is a tiny broadcasting apparatus to be placed on a small bird. Here's a somewhat larger one to be placed on a barred owl. The University of Minnesota has a very sophisticated setup for the study of animal movements by these tiny radar units. Here the barred owl is being put through some contortions, as you can see, but of course without damage to the bird, mounting or placing the harness on the bird. The barred owl was not too happy about this, and he objected a little bit to it, but he was kept in captivity for a while and proved to be able to carry that without any damage. It was then released in the woods, and its movements, short distance movements, were studied by radar for a number of months. And we have literally many months of records of owls that have been been traveling and feeding and living on the Cedar Creek Natural History Area near our station. The station consists of 200-foot towers with rotating directional pickup heads, which pick up signals from as many as 35 individual animals simultaneously, each bringing in a slightly different wavelength signal. These signals are brought into a laboratory by a coaxial cable, and the pickup station looks much more like a physics or an electronics laboratory than a biological laboratory. Each one of the units on the left is picking up signals from a certain individual animal. These flash little lights, which are photographed on 16mm film. The film is then read and the data taken off, put onto punch cards. Punch cards run through computers out onto a plotter, and here a plotter is drawing a map automatically from the punch card data, drawing a map of where the bird or animal has been. A signal every 45 seconds comes in on that apparatus. Here by portable pickup units, radios on geese on this refuge in eastern South Dakota were being picked up, and the birds by triangulation could be located quite accurately, and their movement studied for a number of days. This technique is still, we might say, in its infancy, and many more complicated problems will be studied by this within the next few years or perhaps even months. We had apparatus that a goose could carry that we could pick up a signal from over 200 miles away, and it now seems perfectly possible that a goose carrying a broadcasting unit of this sort can send a signal up, which can be picked up by an orbiting satellite, which could then repeat the signal back down to Earth, and a land station could pick up the signal and determine the position of the origin of the signal within less than 1 mile. So we're on the verge of being able to follow at least large birds and mammals anywhere on the globe. We soon probably can determine whether it is really true, the statement that is often made, that the blue and snow geese from Hudson's Bay make the trip to Louisiana in a single nonstop flight. Some of you may have seen the article in the Audubon Magazine of a year ago. Drs. Graber and Mr. Cochran put a tiny dime-sized transmitter on a thrush down at Urbana. This bird left about 8 o'clock at night. They followed it with a Cub plane, which could pick up the signal at about 2 miles. It flew directly over Chicago, on up the length of Lake Michigan, and was followed by a plane clear up to the tip of the Door Peninsula, over 400 miles from Urbana, keeping at 10 degrees east of north direction, about 40 miles an hour, flying all through the night into a storm in which the plane finally had to turn back. So we now are able to prove that a small bird the size of this scientific skin of a thrush, which gives its size, that a small bird of this type can make flights of this sort and under the conditions which I just described. Now we can actually prove that this is true. Well, we've been talking about the travels of birds by just dotted lines on maps. It will be interesting, I'm sure, to follow a family of snow geese, here an adult and 2 young, for instance, which are nesting, we will say, up on Banks Island in their nesting colony on this Canadian island north of the mainland of Alaska, where a large colony of these do nest. The first after their takeoff from Banks Island, the flock would have to pass over a big arm of the Arctic Ocean called the Amundsen Gulf, possibly flying right over the sprawling little Eskimo village of Coppermine at the mouth or near the mouth of the Coppermine River. They would go on up the river over the rather oddly shaped Copper Mountains, named after fabulous copper deposits which were supposed to be there but have never been found. They go on down to the vicinity of Great Bear Lake. There they probably are joined from the east by the Ross's geese, a small relative of the snow goose, which mingles with the blue and snow geese in migration. This bird nest, the few that are left, are only a couple of thousand, I believe, are supposed to be in existence at this time, of this tiny little Ross goose. They move westward to join up and come south with the other flights down across the east coast of Great Bear Lake, barren rocky shoreline, up in the Arctic tundra, the treeless area of the Arctic. But near the southeast corner of Great Bear Lake, they begin encountering spruce trees growing in the protected valleys. Then a little farther to south, they pick up the aspen groves and fly over a wide belt of hardwoods of aspens in northern Alberta and Saskatchewan, where they begin to see the cultivated fields of westernized man. Here the birds will probably drop in onto some of the lakes in that area, where they will refuel, we might say. And migrating birds, our physiology is set so that they will accumulate fat very rapidly on food that they can pick up at this time of year until they've replenished their fuel supply. Again, in the early morning light, they'll probably take off from these lakes and move south again down across the prairies of Alberta, keeping in next to the foothills of the Rocky Mountains, undoubtedly a guideline at this point, flying over hundreds of miles of the wheat fields of western and northwestern Alberta. Just after they pass over the Montana line into the States, their compasses tell them they turn west and pass through certain of the passes, cloud-filled passes of the Rocky Mountain system, out onto the Pacific coast. A number of the flocks of geese will stop in winter in Oregon. Mostly the blues and snows will stop there. Many of them will go on with the Ross's geese down into the Sacramento Valley just east of San Francisco, where they will drop into situations similar to this, where the Ross goose population and a good many of the blues and snows will winter. Well, many birds throughout the globe make just as long and just as spectacular trips as this on their migration flights. One of the longest travelers among the birds are the sandpipers, and it's a little odd to see this little western sandpiper probing around in the snow and ice way up in Alaska. Why do they go up there when they could just as well stop in tropical regions that would be far more comfortable and to us would seem much more favorable? Actually, the Arctic has had a rather unexplained lure for me, too. For a number of years, for several springs lately, 2 springs, I have spent the spring in Wales, Alaska, on the west tip of the Seward Peninsula, studying the movements of some of these far-traveling shorebirds, such as the long-billed dowitcher here, which I found feeding on snails, which were just being liberated by the thawing of the permafrost just an inch or so under the surface. Another interesting shorebird that was coming ashore there was the red phalarope, a tiny little bird that spends most of its life in the open Pacific west of South America, flying up into the Arctic and coming ashore only long enough to nest and raise its young. I was interested in this point because seabirds moved north through the straits in migration, Siberian birds moved eastward into Alaska, and Alaskan birds were moving westward into Siberia, crossroads for 3 major routes of migration pattern. This does not look like preparations for a May bird trip, but actually it was. This was about the middle of May at Wales, Alaska. We were interested in going out across the sea ice to the open ocean to get a glimpse of the migration of the eider ducks. Traveling over the sea ice was a very rugged type of travel, so we were helped by a few miles of riding on a sled by the Eskimo taking us with his dog team. Up to this point, we then turned and went at right angles to the shore out to the pressure ridge. The dark cloud is reflecting the open ocean, which led the early explorers to call the Bering Sea the Smoky Sea. The pressure ridge is where the moving sea ice jams against the shore ice, buckles it down, and it freezes to the bottom and becomes relatively stable from there on into shore. We could then travel on this portion of the sea ice without danger. So we went out to this ridge of ice some 30 or 40 feet high, climbed up and established our observation post up on top of this particular lookout. And the open ocean was just a few hundred yards beyond. We were warned not to go beyond this, and we soon saw why, because looking out over that and studying the ice very carefully, we could see that the ice was actually moving only a short distance beyond where we were observing. Fairway Rock in the distance. So we set up and began studying with our spotting scopes and doing a few shooting of pictures with telescopic lenses of the migrating flocks of eiders. These are very hardy sea ducks that winter down around the Aleutian Peninsula, the Aleutian Islands largely, some going on south into British Columbia, but the major part of them in the Aleutian area. These birds move very early in the spring when the ice is beginning to move through Bering Strait up into the Arctic Ocean, where they fan out both east and west to Alaska and Canada to the east and Siberia to the west, where they nest on the Arctic tundras along the Arctic Sea coast. These flocks were made up of Pacific eiders, king eiders, spectacled eiders, and probably a few Steller's eiders. Along with the eiders, we identified the Pallas murre, one of the rock ledge nesting birds, which at a distance resembled the eiders considerably, but a little close range we could see they were different. The pattern of the king eider was really quite striking, but they rarely, if ever, came in close enough for us to really get good looks at the color pattern of the eider ducks in these flights. Here a king eider showing up reasonably well. Part of my work was the recording of the color of the soft parts of these birds. This was an adult male king eider that the Eskimo had taken and generously gave me the head because it was the striking big knob on the base of the bill that I was particularly interested in getting a color note on. These change color, of course, after the specimen is dried and brought into the museum. The spectacled eider was really spectacular in the pattern of feathers about the head of this bird. Using these field notes, I, of course, made a few paintings after getting back from the inspiration received from the travels and from the field notes that I recorded. During our stay there at Wales, we were always on the alert for invaders from Siberia. This is not as ominous as it sounds because our invaders were Siberian avian invaders. We did find a number of species were beginning to move across the straits, even that early in the spring, over into Alaska. One of these was the little white wagtail, perhaps one of the rarest of North American birds, because only a few pairs have so far moved over to start nesting on the west tip of the Seward Peninsula, on the west tip of Alaska. And we found a pair of them beginning to build a nest in one of the deserted houses in the village of Wales. Many of you who travel in Europe and Asia are familiar with this bird. This species is also beginning to invade North America from the east. And if we swing our map around, we'll see that here, taking off from Scandinavia and the British Isles and hopping over by way of Iceland, the little white wagtail has begun to invade the east coast of Greenland, and a few pairs are nesting there at that point. So these are the only places in North America where that species occurs. The little red-throated pipit is another species that has begun invading but has gotten a little farther in its gradual moving into the North American continent as a nesting bird. This has also moved in from Siberia and has taken over a somewhat larger area of western Alaska. The yellow wagtail has extended its movement still farther, and it has taken over about half of the peninsula of Alaska as a part of its breeding range. All of these birds, so far that we've mentioned, move back to Siberia to migrate south in the wintertime, and do not migrate south with the other local birds nesting with it in Alaska. These go down to the Philippines and Malaysia and southern China to winter. The wheat-ear has gone still farther with this invasion of the North American continent, and this bird is found over almost all of Alaska. It's rather a long-legged relative of the bluebirds in the thrush family. Very, very cautious little bird, hard to approach and photograph. Here it has taken over most of Alaska, and some of these birds are beginning now to winter at the base of the Aleutian Peninsula, indicating that the bird is very gradually becoming acclimated to the North American continent and will probably soon become a regularly established breeding bird in North America. The race from Europe has moved into northern Greenland, Baffinland, Labrador, and is beginning to invade from the east. The snow bunting, on the other hand, is a little northern bird, one of the small songbirds that nests farther north than any other bird in the world. This bird, we are not sure where it originated and whether it invaded North America from Siberia or Siberia from North America, because it has now become well established as a circumpolar nesting bird. And those birds that nest in northern Canada and Alaska move south into the States for the winter. Those that are nesting in northern Europe move down into Italy and Asia Minor. Those nesting in northern Siberia move down into Mongolia, China, and central Siberia for the winter. The longspur, the Lapland longspur, has nearly the same range as the snow bunting, but does not nest quite as far to the north. One afternoon, we did get in on a rather spectacular flight of birds, of North American birds, going to Siberia. This was the 23rd of May, although this looks more like the 23rd of December or January to us. We almost decided not to go out because it was so blizzardy that any birds would not be active at all, but we did know that a pair of ravens were nesting up on the top of Wales Mountain, and we thought we could photograph them even if nothing else was stirring. These had half-grown young already by the middle of May. This is one of the very, very hardy northern birds. While we were watching the ravens, we saw these large birds flying out over the ice below us, and with our binoculars we soon recognized them as sandhill cranes, the lesser sandhill or little brown crane. Looking back inland, we saw flock after flock coming almost at eye level out to the tip of the peninsula, and when they got out to the tip of the Seward Peninsula here at Wales, they appeared not to want to go out at low levels over the sea ice. So the flocks began breaking up their formations and began circling, moving up and up, apparently in order to get higher elevation to see Siberia. These birds have been nesting in Mexico and southwestern states. Some moved up the west coast, others through the Great Basin, others moved northward through the western edge of the Great Plains, clear across the U.S., clear across Canada, across the length of Alaska, and now they were jumping across the Bering Straits, 60 miles across to Siberia, where a good many of these birds were to nest. As they circled higher and higher, it really became quite a spectacular sight. The clouds cleared, the weather cleared up. Apparently these birds had been blocked by bad weather for several days, and now with the clearing of the weather, large numbers began moving. We estimated between 15 and 20,000 moved over our heads during that afternoon. And it really, we were unwittingly occupying ringside seats, you might say, to a very spectacular movement of these birds. The sun late in the afternoon, reflecting and shining up onto their wings, made them look almost pure white with black wingtips against the blue sky. But of course they were not whooping cranes, but the little brown. Several flocks at different altitudes, you'd get several layers of birds. Here was the Little Diomede and Big Diomede Island, which they were spotting en route over to their flight to Siberia. The raven sometimes circled with the birds. 2 or 3 layers of these birds against the blue sky was really a spectacular sight. Well, we're leaving the birds now, turning back to man, and even with all of his jet planes and his other mechanical devices for travel, man is only now beginning to rival the birds in his ability to travel over the surface of the earth. And the percentage of people who are even now traveling to other continents and to far distant parts of the world is very small as compared to the proportions of the population of many birds which are making intercontinental flights in their migration travels. And the spectacular thing about this is, the remarkable thing about it is, that these birds are all supplying their own power, flying at sometimes tremendous elevations, and guiding themselves with their own innate knowledge of direction. How they are able to do all these things do constitute some real migration mysteries that still have to be solved. Most of us will still use bird study probably as just an absorbing hobby, but the young biologists who are coming up and looking for some good, interesting, really quite exciting problems to try to solve might attempt to set up some experiments which will give us some more factual information about how these birds are able to make these long flights.